Hey everyone, in today's video we are going to discuss about design web crawler. Now, when you are asked this question in an interview, you should first clarify the requirements because there are many different purposes of web crawler. For example, we can use web crawler for search engine indexing. This is the most common use case. A crawler collects web pages to create a local index for search engines. For example, Googlebot is the web crawler behind the Google searching engine. Second, we can also use web crawler for web archiving. This is the process of collecting information from the web to preserve data for future uses. For instance, many national libraries run crawlers to archive websites. Third, we can also use it for web mining. The explosive growth of the web presents an unprecedented opportunity for data mining. Web mining helps to discover useful knowledge from the internet. For example, top financial firms use crawlers to download shareholder meetings and annual reports to learn key component initiatives. And last one, web monitoring. The crawlers help to monitor copyright and trademarks infringements over the internet. For example, Digital Map utilizes crawlers to discover pirated works and reports. In today's video, we are mainly going to focus on search engine indexing. So, let's focus on functional and non-functional requirements first. Functional requirements. So what are the main core functionality for search engine indexing? The core functionality is, first, we need to collect data. We need to fetch pages. As part of fetch pages, it will be basically like download HTML, display character encoding, save raw content, and metadata. And second, once we have this data, we need to rank or index pages. Basically, like we need to have compute ranking signals, we need to consider freshness and usability signals. Now, next, we will discuss about non-functional requirements. Scalability. Scalability is very important for non-functional requirements. The web is very large. There are billions of web pages out there. Web crawling should be extremely efficient using parallelism. Second, robustness. The web is full of traps. Bad HTML, unresponsive servers, crashes, malicious links, etc. are all common. The crawler must handle all those edge cases. Third, politeness. The crawler should not make too many requests to a website within a short time interval. We want to make sure that we don't bring down the website servers. Fourth, extensibility. The system is flexible so that minimal changes are needed to support new content type. For example, if we want to crawl image files in the future, we should not redesign the entire system. So, these are the main functional and non-functional requirements we are going to focus on in today's video. So, now let's start with our high-level design. In high-level design, we will first focus on functional requirements and then we will go with non-functional requirements. And in this case, the web crawler, basically we are going to focus on search indexing pages, which needs basically like getting the content first. And how do we start with that first point? The first point to start will be seed URLs. Seed URLs. For example, to crawl all web pages from a university's website, an intuitive way to select seed URLs is to use the university's domain name. To crawl the entire web, we need to be creative in selecting seed URLs. A good seed URL serves as a good starting point that a crawler can utilize to traverse as many links as possible. The general strategy is to divide the entire URL space into smaller ones. The first proposed approach is based on locality, as different countries may have different popular websites. Another way is to choose seed URLs based on topics. So, you can think about which way you want to go with it and then start with the seed URLs. Once we have seed URLs, then the request will go to URL frontier. Most modern web crawlers split the crawler state into two: to be downloaded and already downloaded. The component that stores URLs to be downloaded is called the URL frontier. You can refer to this as first in, first out, or FIFO queue. Now, once we have URL frontier, the request will go to HTML downloader, whose job will be basically to download the HTML To get HTML, we first need to get the IP address of the server. So it will send a request to DNS resolver, whose job is basically to get the IP address to resolve the DNS. So the HTML downloader will send a request to DNS resolver. And once we get the IP address from DNS resolver, we know from where do we get the content of that particular domain. So we will get the content and then it will send a request to content parser. After a web page is downloaded, it must be parsed and validated because malformed web pages could provoke problems and waste storage space. Implementing a content parser in the crawl server will slow down the crawling process. Thus, the content parser should be a separate component. Now, once we already got the content parser, we need to see if those kind of content already stored in the database, it's already seen, or maybe it's a duplicate content. So we will create another component called content scene, whose job will be just to verify the duplicacy of the content. If contents are not duplicate, then we will store these into our database. Now, once we already got the content, the content might be just HTML or it might be containing a lot of other different links, which we need to still look into it. So we need to implement URL extractor, whose job is basically to pass and extract links from HTML pages. So as an example, when you are using w3schools.com, one page might have many other links internally, like maybe you're learning JavaScript or you're learning something else. So we will extract those links from the main domain and then we will start filtering it out, all the required URLs from the URL extractor. So we will have URL filter, which will exclude certain types, as an example, like certain file extension. For example, there might be some links which just includes images or which includes text files, etc., which we don't need to really get the content from those kind of files. So URL filter's job is to figure it out which kind of URLs are there and should we seed them again to parse the content and save in the database. So once we have URL filter and once we get the actual URL from here, we will have a component called URL scene, whose job is basically to check the duplicacy of the URL. And if URL is not already seen, is not used before or is not done before, then we will store this URL into URL storage. And again, if it is a new URL, that means we need to get the new content. We need to get the content of this URL too. So what we'll do in this case is all those new URL will go back to seed URLs again, and this whole process will continue. So this is going to be our high-level design in terms of web crawler. Now, let's discuss about deep dive. In high-level design, we discuss about major components, and in deep dive, we will discuss about all the non-functional requirements as well as what should be taken care of at each component, which is very critical. So first, let's start with seed URLs. Seed URLs, as we discussed in high level, basically it gets on the URL and patches and then sends it to URL frontier. Now, think about it, one of the website called W3 Schools or Wikipedia or anything like that, right? When you're going through one of the homepage on w3schools.com, there will be a lot of links associated in that page, in the one page. And we need to check each and every page URL by URLs which are on that page and go through it. So there are two algorithms to get all the URLs from the given URL page. So there are two algorithms. One of the algorithm is called DFS, depth first search, and another is BFS, breadth first search. Now, when we think about DFS, we can go in as much depth as we can go, but that will create a problem, which is there might be maybe in some of the domain, it might be only 3 depths versus some of the domain might have depth up to 10 level or up to 20 level, or maybe more and more, or sometimes people might have created a spider trap, which is basically you keep going in depth and it might stuck into infinite loop and then our web crawler will break. So DFS is not a great algorithm to follow with this one. BFS is a better algorithm to follow when we are having SIG-URL. BFS is basically breadth search. Now, when we are using BFS, what happens is like there are two types of problems can occur. And one of the problem is basically when you're reading like W3 schools, I was so continue with the W3 school example. When you are going through it, all the links on particular page will still send you back to the same host. And in that case, what will happen that if you keep using it, then there might be a politeness issue, which is like if you keep sending all linked URLs which are associated to the same host W3 schools, you might be sending more than 10 requests in a second, and that will overwhelm the server. That's one of the problem. And second problem can occur, which is like deciding priority of the URL. Like BFS does not consider priority of URL. It just blindly takes all the URLs and keep continuing and keep feeding the URL to URL frontier. Now, we can resolve this issue, and that issue will be resolved at URL frontier level. So URL frontier will basically consider above URL prioritization, freshness, as well as politeness. Now, URL prioritization, why is it needed? Like we need to consider URL prioritization issue based on multiple criteria, which is like based on the traffic of the URL, frequency of the URL, and freshness of the URL, and there are many more things we need to consider. So URL prioritization, we will discuss in how does it work. So that will be a queue prioritization or prioritizer, and this prioritizer or prioritizer will send requests to all these different queues, F1, F2, Fn, like basically like that will be like many queues based on number of URLs, and then this queue has an assigned priorities. Queue with high priority are selected with higher probability, and queue selector, basically, it will randomly choose a queue with a bias towards queue with high priority. We should always consider high priority because it means those URLs are frequently being used, or those has high traffic, or they might have like better load, etc. So this is how prioritization will work, and this is how priority of the URL will be decided. Once we already got the priority of the URL, we need to send the request to backqueue router. Basically, this component specifically will discuss about politeness. How do we maintain politeness? So basically what happens at this level is this queue router, it answers that each queue B1, B2 up to Bn only contains URLs from the same host. We always need to maintain that we always use the same host when we are using this row. Then FIFO queues B1, B2 to Bn, each queue contains URLs from the same host. Then queue selector, basically each worker thread is mapped to a FIFO queue and it only downloads URLs from that queue. The queue selection logic is done by the queue selector. And then each worker thread downloads web pages one by one from the same host. And there will be a delay can be added between two download tasks. And that delay will basically maintain the politeness of the URL. And this is how like we need to think about like politeness. So overall, like first the prioritizer will decide the priority of the URL, then this queue selector will send a request to backqueue router, and this backqueue router basically will maintain the politeness of the website. So that way we don't bring down the server, and we always make sure that other server or the website doesn't think like it's a DDoS attack or anything like that, because politeness is important. If you start sending suddenly like more than 100 requests per second, the beat might also be now the other website server, which is not great experience. So this is how we will maintain like in terms of prioritization and politeness. The next one is freshness. I would like to just discuss freshness at high level, which is like, there are millions of pages, but there are certain pages which have fresh content, and some pages like they hardly change. Let's say like they created a blog which is just needed to be used for one time, some kind of promotion or some kind of marketing strategy, and then after one time they might not like that blog might not have real useful content, so we don't need to use that blog after 1 year of the blog is created if there is no content updated, versus let's say there is an Apple website on the Apple page and they will have constant updates related to changes or what's coming next, etc. And Apple is like a very well-known domain, so it will take higher priority because it has fresh content. So we need to prioritize freshness based on the freshness based on certain thing, which is like recrawl based on web pages update history, and prioritize URLs and recrawl important pages first and more frequently. So that's how like we will maintain the freshness for the URL. So these are the main components in terms of like deep dive, and we already discussed about like politeness, prioritization. Now I would like to discuss about extensibility. Why extensibility is important? So extensibility is important because like currently we are thinking about just extracting URL, but we also need to think like when we are extracting URLs, there might be a chance that some of the URLs are just for PNG. Some of the URLs are maybe for other URLs who are the actual host website, like host subdomain, etc. And there will be some of the URLs which are just related to files, etc. So we should create extensibility in a way that any new URL type we have to take care of it. It should be an extensible module. So we just add the module and it can take care of the type of the URLs. And that way, like in future, if we need to do certain type of work, we just extend the module and it will be easy to maintain. Now, let's discuss about robustness. Robustness, that is also very important because this is like we can consider robustness in very different ways, multiple different ways. First, consistent hashing. This helps to distribute loads among downloaders. A new downloader server can be added or removed using consistent hashing. We can also save crawl rate states and data. To guard against failures, crawl states and data are written to a storage system. A disrupted crawl can be restarted easily by loading saved states and data. Then, we should also consider about exception handling. We should handle exception or errors at every stage. Errors are inevitable and common in a large-scale systems. The programmer must handle exception gracefully without crashing the system. And then we also should consider about data validation. This is a very important measure to prevent system errors. And this is how we will consider about robustness. And the last non-functional requirement, which is scalability. So we need to consider system scalability almost every stage, because think about it, like you can have scalability at URL frontier level, but what if like URL filter is not scalable, then also our system can break. So how should we maintain the scalability? How do we make sure that system is scalable? So at each level, I would say like consider URLs or URL frontier or HTML downloader, we should have multiple servers. And when the traffic load increases, we can just increase more servers if it's needed. That way system will be always scalable. For storage level, like we should also have multiple databases. We should have master and master-slave replication. We should have master-slave implementation where we also should have replication. So we should use like our main database, master database for writing versus replicative database just for reading data. So that way like we can also improve the performance of the system. Another thing is DNS resolver. As I mentioned earlier, like we can also use like multiple DNS resolvers. So what happens is like when HTML download gets a request, and if it keeps sending requests to same DNS resolver, and for any reason, if that particular DNS resolver is down, we can still send requests to another DNS resolver to get the IP address of the domain. Another thing is like we should cache the content at HTML downloader level, especially like in terms of IP, so we can reduce the request to DNS resolver. That way we don't overwhelm DNS resolver as well. So basically like we should consider scalability almost every stage as we discussed, and this is how we are going to take care of about our non-functional requirement. So in a summary or in a nutshell, I will say that in deep dive, we discuss about sync URLs, like we discuss about DFS versus BFS, and we also discuss about almost all non-functional requirement in terms of scalability, robustness, politeness, extensibility. And at high level, we also discuss about the major component of the systems which we needed. Thank you for watching the videos, and if anyone have any questions, feel free to put it in the comments. And if you would like me to discuss about any other system design in my future videos, please feel free to put the comment. Thank you.